DevOps and CI-CD Part 11. This episode has 6 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain private registries. Here's a strong way to approach it. What is a private container registry? A private container registry is a container image repository that restricts access to authorized users, systems, and services. Unlike public registries, images stored in a private registry are not accessible to everyone on the internet. Why use private registries? Organizations use private registries to store proprietary application images, protect intellectual property, control access using authentication and authorization, meet compliance and security requirements, integrate with enterprise CI or CD pipelines architecture. Developer. The exact commands and code are in the written question bank. Nice. Let's continue. Question 2. What is OC? Here's a strong way to approach it. What is OC? OC, Open Container Initiative, is an open industry standard that defines specifications for container images and container runtimes, ensuring containers work consistently across different platforms and tools. OC was established in 2015 by the Linux Foundation with contributions from companies such as Docker, Google, Microsoft, and others. Why OC was created? Before OC, different container platforms could implement incompatible formats. Portability between tools was not guaranteed. OC standardized 1. Container image format. 2. Container runtime specification. This allows images and containers to run across different OC-compliant tools. OC specifications. 1. OC image specification defines how container images are structured. Example: Docker image. OC image format registry. An image built by Docker can be used by other OC-compliant runtimes. 2. OC runtime specification defines how a container should be executed. Example: OC runtimes. Runt cron gvisor kata containers. OC ecosystem container image. OC image spec container registry. Containered runt. OC runtime. Container Docker and OC modern. Docker is OC compliant when you run Docker run ginks internally. Docker CLI Docker engine. Containered runt. Container runt follows the OC runtime specification. OC in Kubernetes. Kubernetes relies on OC compliant container runtimes such as Containered CRIO. This allows Kubernetes to run containers without depending directly on Docker. Benefits of OC. Checkmark. Vendor neutral standard. Checkmark. Portability across platforms. Checkmark. Interoperability between tools. Checkmark encourages ecosystem innovation. Checkmark prevents vendor lock-in. Checkmark standardized image and runtime formats. Interview answer: 7+ years experience. OC, or Open Container Initiative, is an open standard under the Linux Foundation that defines specifications for container images and container runtimes. The OC image specification standardizes how container images are packaged and distributed, while the OC runtime specification defines how containers are executed. Tools such as Docker, Containered, CRIO, and Runt are OC compliant, enabling interoperability across container ecosystems. OC plays a critical role in Kubernetes and modern cloud-native platforms by ensuring portability and preventing vendor lock-in. Great. Moving on. Question 3. Explain container networking. Here's a strong way to approach it. What is container networking? Container networking is the mechanism that enables containers to communicate with other containers, the host machine, external networks, and the internet. Since containers are isolated by default, networking provides connectivity between them and other systems. Why is container networking needed? Consider a web application. Frontend container, backend container, database container. For the application to work, frontend must reach backend, backend must reach database, users must reach frontend. Container networking enables these communications. Docker networking architecture. Container A, Docker network. Container B, each container gets an IP address, network namespace, routing table, DNS resolution. Docker network types. 1. Bridge network. Default. Most commonly used on a single host. Docker network LS default bridge. Docker Rundin Ginks architecture. Container A, Docker bridge. Container B, containers on the same bridge can communicate to host network. Container shares the host's network stack. Docker Run network host Ginks advantages: better performance, no NAT overhead. Disadvantage: reduced isolation. 3. None network, no networking. Docker Run network none Ginks container has only loopback interface. 4. Overlay network used for multi-host communication in Docker Swarm and Kubernetes. Node 1 Container A Overlay Network. Node 2 Container B allows containers on different hosts to communicate. Container 2 Container Communication. Create network. Docker network. Create app network. Run containers. Docker run D. Name DB. Network app network. MySQL. Docker run D. Name app. Network app network. My app application can connect using DB 3306. Docker provides built-in DNS resolution port mapping. Expose container service externally. Docker run page 8080. 18 ginks meaning host port 8080, container port 80, access HTTP or localhost 8080. Networking in Kubernetes. Kubernetes networking model requires every pod gets its own IP. Pods can communicate without NAT. Services provide stable access to pods. Pod A service, Pod B common CNI plugins. Calico Cilium Flannel networking components. Behind the scenes Linux features used by containers. Network namespaces. Virtual Ethernet. VETH. Pairs Linux bridges. Iptables or NF tables. Routing tables. Flow. Container VETH pair Linux bridge. Host network. Internet interview answer. 7+ years experience. Container networking enables communication between containers, hosts, and external systems while maintaining isolation. Docker provides networking modes such as bridge, host, none, and overlay. By default, containers are attached to a bridge network and can communicate using IP addresses or Docker's built-in DNS. In Kubernetes, each pod receives its own IP address, and communication is managed through the CNI layer using solutions like Calico or Cilium. Under the hood, container networking relies on Linux network namespaces, VETH pairs, bridges, and packet forwarding mechanisms to provide connectivity and isolation. Alright, next question. Question 4. What are bridge networks? Here's a strong way to approach it. What are bridge networks? A bridge network is Docker's default network driver that allows containers running on the same host to communicate with each other through a virtual bridge. When Docker is installed, it automatically creates a bridge network called bridge. How it works: container A 172.170.2, Docker 0 bridge, container B 172.170.3, host network. Each container gets its own IP address. Docker creates a virtual Ethernet VETH pair for each container. Traffic passes through the Linux bridge. Docker 0 default bridge network. View networks. Docker network ls example output. Network ID name driver XX bridge XX host XX null. Inspect the bridge network. Docker network inspect bridge. User defined bridge network. Create a custom bridge network. Docker network create my network. Run containers. Docker run D. Name app. Network my network ginks. Docker run D. Name DB. Network my network. MySQL containers can communicate using container names. DB 3306. Docker provides automatic DNS resolution within user-defined bridge networks. Bridge network features container to container communication. Web container bridge network. DB containers on the same bridge network can communicate directly. External connectivity. Containers can access the internet through NAT container. The exact commands and code are in the written question bank. Let's keep going. Question 5. Explain host networking. Here's a strong way to approach it. What is host networking? Host networking is a Docker network mode where a container shares the host machine's network stack directly instead of getting its own network namespace and IP address. In this mode, the container uses the host's IP address, the host's network interfaces, the host's ports. Architecture. Bridge network. Default. Container. The exact commands and code are in the written question bank. On to the next one. Question 6. What is overlay networking? Here's a strong way to approach it. What is overlay networking? Overlay networking is a networking mechanism that enables containers or pods running on different hosts, nodes, to communicate as if they were on the same network. It creates a virtual network on top of the physical network, abstracting the underlying infrastructure. Why do we need overlay networks? Imagine node 1, node 2. Container A, container B 1.0.1.2.1.0.0.2.3. Normally, containers on different hosts cannot directly communicate using private container IPs. An overlay network provides a virtual network. Container A 1.0.2.4.4.1.2. Overlay network. Container B 1.0.2.4.4.2.3. Now they communicate seamlessly across hosts. Architecture plus. Container A plus plus, plus, overlay network plus, plus plus, plus, container B plus underneath, container. The exact commands and code are in the written question bank. Good, here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.